Suppose a plus b plus c adds up to pi radians. We need to show that sine squared a plus sine squared b minus sine squared c that equals to 2 times the product of sine a, sine b and cosine c. Okay, let us begin. So here we're going to start our proof from the left hand side. So on the left hand side, let's note down the expression. We have sine squared a added to sine squared b minus sine squared c. What we will do is we are going to combine sine squared b minus sine squared c first. So here there's a standard formula. So whenever we have sine squared alpha minus sine squared beta, this is given by sine of alpha plus beta multiplied to sine of the angle alpha minus beta. Fine. So now what we have is sine squared a added to sine squared b minus sine squared c. Using the formula, we should get sine of b plus c multiplied to sine of the angle b minus c. Okay, now furthermore, we're going to use the condition that a plus b plus c equals to pi to change sine of b plus c. That means since we have a plus b plus c equals to pi radians, now what we can do, we can transpose a to the right hand side to get pi minus a. Now we're going to take the sine on both sides. So sine of angle b plus c, that is going to be equals to sine of the angle pi minus a. And we know that sine of pi minus a, that's simply given by positive sine of a. Getting a positive sign because pi minus a indicates we are in the second quadrant while the sine function is positive. So here what we have done, we have shown that sine of b plus a, this is the same as sine of angle a provided a plus b plus c equals to pi radians. Now our expression is going to become, so we have sine squared a added to, in place of sine of b plus c, we can replace it with sine of angle a multiplied to sine of angle b minus c. Now what we can do, we can take sine of a as the common factor. So we have sine of a, this is going to get multiplied to sine of angle a plus sine of angle b minus c. Okay, in the next step, what we can do, in place of sine of a, we have already showed that it's equivalent to sine of b plus c. So we can replace the sine of a within the parentheses with sine of angle b plus c added to sine of angle b minus c. Fine. Now what we have is the sum of two sine function, and we can combine two sine function with using the formula. That means if we have sine of alpha added to sine of angle beta, this is going to be equals to 2 times the product of sine of alpha plus beta over 2 multiplied to cosine of the angle alpha minus beta over 2. Okay, so let's use this, and now we're going to get 2 times sine of angle a multiplied to sine of, so we need alpha plus beta. So here alpha, let us suppose that's equivalent to b plus c, and b minus c is beta. So b plus c added to b minus c, that gives us 2b, and when it's divided by 2, we're going to get sine b multiplied to cosine of, now we need b plus c minus b minus c, so that's going to simply give us 2 times c, but we have divided by 2, so that gives us c. So this is exactly the expression on the right hand side. So we can say thus we have successfully showed that the left hand side equals to the right hand side, hence proved.